Okay, welcome to my channel again. And now I am continuing from my previous lecture and on the same topic, that is the first part of the GATE syllabus, database concepts, attributes, topics, keys, and year model. Now I'm starting with question number 5, which is a GATE question of in the year of 2005. And in this question, a table is given where two attributes are there, A and C, where A is the primary key. C is the foreign key referencing A with on-delete cascade. The set of all tuples that must be additionally deleted to preserve referential integrity when the tuple 24 is deleted is. Basically the question says that A is the primary key and C is the foreign key referencing A. So this means the attribute A and C are same because one is primary, another one is foreign key. Now, the preserving referential integrity, we know that cascading delete is the option, and the options are 3464, 5272, uh, as well as C and D. Some options are there. Now, when we delete some row and we have to check the primary key, if the primary key is deleted to preserve the referential integrity, the foreign key, if any time in any table the same primary key is represented as a foreign key, we must need to delete that row too because it is now referencing nothing. So when 24 is deleted, we have to find where 2 is there as the foreign key. So the solution, it is the hints of the solution. I'm going to my explanation. In this explanation, A is the primary key and C is the foreign key. As I have told that A and C are same because one is referencing another and the relationship is primary key and foreign key, so they both are same. Now the thing is that while an entity in the C referencing A with on-delete cascade with referential integrity means while an entity small e having values A and C is deleted, there is no issue or problem is that C is deleted. Okay, but A is a primary key and it is deleted. So in the remaining table where foreign key value is A now has no significance as there is no primary key of value A exists. So as per the statement we can see that the primary key 2 where it is presented as a foreign key. If you see the 2 here, 2 for this row is deleted and 2 is present as foreign key here and here. So 52 and 72 must be deleted. Now the same rule will be applied to this for this row and this row also. So whenever 5 is deleted, we have to find where 5 is acting as a foreign key and it is here. So 9 5 will also be deleted. Okay. Now we have to find 9 also. 9 is not there as foreign key anywhere. And also 7 we have to find. So 7 is also not there as a foreign key. So there is nothing to delete. So the main deletion will be 2 4, then 5 2 and 7 2. This will be the answer. And that's why C is the correct answer. Okay. Okay. Thank you. Now the next question is that there is a year diagram where two entities are there, E1 and E2. One relationship is there as shown in the figure, that is R. The cardinality is 1 to M from E1 to E2 under the relation R. The attributes of E1 are A11, A12, A13, where A11 is the key, and for attribute for E2 are A21, A22, A23, or A21 is the primary key. Another thing is mentioned that A23 is a multi-valued attribute. Okay, so only one multi-valued attribute is there also for the entity E2, and that is A23. Relation R does not have any attribute. Okay, a relational database containing minimum number of tables, with each table satisfying the requirements of the third normal form, that is transitive dependency is not there, is designed from the above ERD. The number of tables in the database is, the options are 2, 3, 4, 5. Okay. So here, according to the question, the main thing is the multiple value attributes. Okay. Because when we see the cardinality 1 is to m, as per my discussion in the previous lecture, I can say you that there will be only two tables. Anybody can say. But the thing is, multi-valued attributes belong to the entity E2. So this is the main thing, that's why the question is important. And it is explained as it is. The main part is there, multi-valued attribute. So the table for E2 is divided into two. One with all the attributes except the multi-valued attributes, and another one is with the primary key and the multi-valued attribute. So what will happen? The table which is associated with E2, there remember that there are two tables only. One is for E1, one is for E2, and the primary key of E2 will be saved in the table of E1. And there's no table for R. That's why the mapping is already done, as it is 1 is to m. Okay. Now the thing is, multi-valued attribute exists. So now initially, as there is a cardinality of 1 is to m, then no to prime, that I have told already. Okay. But the E2 divided, the table for E2 is divided into two, one with all attributes except the multi-valued attributes, and another one is with the primary key and the multi-valued attribute. Okay. So ultimately, there will be three tables. One is for associated with E1 and another two is associated for E2. So the ultimate answer will be 3, and that's why the option B is correct. Okay. Now the next question is, comes in GATE 2024, a ER relationship, entity relationship, ER diagram. Which one of the following statement is true? Option A, the weak entity set must have total participation in the identifying relationship. The owner entity set must have total participation in the identifying relationship. Both the weak and owner entity sets must have total participation in the identifying relationship. Neither the weak entity set nor the owner entity set must have total participation in identifying the relationship. The thing is that it is a weak and strong entity ER data model, where we know that weak entity set must have a total participation in the identifying relationship. It is true. Now that owner entity, obviously the owner entity set must have total participation in the identifying relationship. It is false. Okay. But let me see the explanation. Okay. A weak entity cannot exist without an owner entity. It is true. Okay. For example, a student entity cannot exist without a department entity. because without the department, the student cannot exist. And the primary key of the owner entity must be in the table of the weak entity. Okay, but it will never be that the primary key of weak entity will be in the table of strong owner entity. Okay, so this statement that uh, C, both the weak and owner entity sets must have total participation in the identifying relationship. It is false because weak entity must not have owner entity must not have a total participation. Weak entity may have, obviously. B is also incorrect in this context. B, the owner entity set must have total participation. It is completely wrong. Okay, the weak entity set must have total participation, and it is right. So the option A is correct. Okay. Now the next question is question number 8. It came in GET in the year of 2024. They have given 4 diagrams that is shown in the right side, and some description is also there. Let S be the specification. Instructor teaches courses. Students register for courses. Courses are allocated classrooms. Instructors guide students. Which one of the following year diagrams correctly represent S? Now, when we see the year diagram, we have to follow the descriptions given and the entities. We have to remember the basic thing of year diagram, that entities must be related with at least one relation. Okay, so these are the basic. So let me see the explanation. In the explanation, in one, no relationship between course and registration. If I see one, there is no relationship between course and registration. So it is incorrect. Simply it is incorrect. In two, there is no relationship between classroom and allocation. Sorry. In two, project is a new entity, and whether course is related or not, we don't know, but it's shown here. Project is a new entity. If you see the question, there is no entity named projects, okay? But it is here. So that's why it is incorrect. In three, it is a completely wrong year diagram because one relationship comes from the course entity, okay, but to whom it is related to is not defined. Another classroom and course, they are not related. But if you see 4, it is completely right because as per the question, instructor teaches courses. So instructor teaches courses. I see this here also. Instructor teaches courses. Student register for courses. Student register for courses. Registration relation is there. Instructor guides students. Instructor guides students. So all the relationships are covered as well as all the entities, and no extra relationship is there. That's why 4 is correct as per the question. Okay. Now from now on, I am discussing now the questions with 1 marks, which comes in the previous years. Uh, the first one of the question like this: which one of the following is used to represent the supporting many to one relationship of a weak entity set in an entity relationship diagram? Okay, so it wants to know the weak entity relation, and the options are diamonds with double or bold border, rectangles with double or bold border, ovals with double or bold border, ovals that contains underlined identifiers. First of all, I want to say that ovals are represented, ovals are used to represent attributes. So C and D are wrong. And D, rectangles are used to represent entities. That is also wrong. Diamonds with double and bold border is correct because whenever weak entity we have to use double border, okay, and as well as bold, and it is look like this the right side figure, okay? And that's why the option A is correct. The next question is which of the following is not a super key in a relationship schema with attributes BWXYZ and primary key BY, okay? As per the definition of super key, any super key, any primary key is a subset of a super key. It may be a proper or it may be an improper subset. Okay, so primary key must be a subset of a super key. If it is true, then Vy must be a part of the super key. And the question is whether it is a super key. These options you have to choose which one is the super key. Now where Vy is there? Now in option A, Vy is there. Option B, Vy is not there. Option C, Vy is not there. Option D, Vy is there. So only in B, Vy is not there. So we can easily say that B is not a super key. Okay. The explanation is just I have told. It is like that. Next question. Here is a student relation. Our student ID, student name, student email, student age, and their CPI or marks is there. Now the question is one statement is there, student name and student age to be the key for the instance. Okay, here student name and student age is a key. That means in any row the value, the joint value of these two attributes will not be same if it is a key. That is the definition of a key. Now they ask the value of x should not be equals to. So what will be the value of x? That I may not know, but it should not be something. That is the question. And look at student name and student age is a primary key. Now student name is Shankar. Shankar is common in different rows. Here in first row, here in third row. Okay. Now in the third row, the student age is given as 19. Now as they both conjugately represent a primary key, that is Shankar and 19, must not be same to another row. There may be one attribute may be same. For example, Shankar is common here, but x should not be 19. Otherwise, they both will be same and they will not be the key. The constraint will be violated. So hence the answer will be B, 19. The explanation given here is the same. I have written in this red one. They are both same, and so x should not be 19. And so the option B, 19 is correct. Okay. So up to this, I have discussed for this topic here. The remaining questions will be discussed in the next video. Thank you.